Hello my dear students, welcome back to my channel. My name is PrachiSharma and in today's session we are working on part 2 of Mole Concept Important Questions. So a lot of students reached out to me on email and telegram asking that ma'am, you always solve the questions and then we are just trying to copy that or understand that from the lecture. So why don't you just give us a few questions to practice out similar questions that you have solved in the video. So in today's session, I'm gonna do exactly that. So towards the end of the session, I'll be giving you questions for homework. So let's say in the beginning we are solving a few questions. Towards the end, you'll have about 10 to 15 questions on the similar pattern as homework. So without wasting any time, let's get started. Alright students, let's get started with today's questions. So the first question says, choose the correct answer from the options given below, and the first portion is the vapor density of carbon dioxide is given. And okay, so vapor density, you're supposed to calculate the vapor density. So they are saying choose the correct answer from the options given below. The vapor density of carbon dioxide is what? And then they have given you the options. So what formula we'll be using in this case is you'll be using vapor density, molecular mass equals 2 into vapor density. Carbon dioxide is given to you, CO2, and then they have given you the masses. So you're going to calculate the total molecular mass or relative molecular mass for carbon dioxide. So that would be C is 12 plus 16 times 2. So 12 plus 32, which is 44. So that is that you'll put over here. So that would be 44 divided by 2 equals vapor density. So 22 is your vapor density. So which one of that is? Your D is the correct answer. Let's move on to the next one. The gaseous hydrocarbon contains 82.76 of carbon. And they are saying given that is vapor density is 29, find its molecular formula. Okay, so a gaseous hydrocarbon contains 82.76% of carbon. Okay, so we are going to solve that. It's a hydrocarbon, so that means they have given you the carbon percentage. Whatever is left out after subtracting that from 100 is your hydrogen content. So let's start with that. So whenever we have empirical formula questions, we make a chart. So let's quickly do that. The first will be elements, percentage, composition, then atomic weight, then you will have relative number of atoms, and then you have simple ratio. Okay, so this is what is your basic way of writing it. Since I'm doing it faster, I'm just gonna make it rough and I'm gonna use a quick calculator for making calculations a bit faster. So let's quickly do that. So you have carbon and hydrogen. Carbon they have given 82.76. What is left out? You'll be left with 4 and 2 and 7 and 1. So you'll have 17.24, and then atomic weight is 12 and 1. Relative number of atoms, so you divide them. So 82.76 divided by 12, I'm gonna get 6.89, and then this is 17.24. Now divide both of them by 6.89. So how do you pick that up? Whichever is the lowest number, divide both of them by that number, or all of them by that number. So lowest is 6.89. Divide all of the relative number of atoms by 6.89. So once you do that, you get the simple ratio. So this one will give you 1, and if I have 17.24 divided by 6.89, I'm gonna get 2.5. And then since you have 2.5, you cannot use a decimal number, you have to make it whole number. So you multiply both of them by 2, so you end up getting 2 and a 5. So this is your final simple ratio. You can make the empirical formula now. So empirical formula would be C and H. Carbon is 2 and H is 5. So C2H5. This is your empirical formula. The next part of the question is they have given you the vapor density, that's 29. Find its molecular formula. So the first thing, using vapor density, you will calculate the relative molecular mass. So let's do that. So relative molecular mass equals 2 times vapor density. Vapor density given to you is 29. So 2 times 29 is your relative molecular mass. So once you calculate that, so this will, let me just leave it like this because I'm anyways gonna use it later. Then you can use the formula, that is N. Do you remember? You have to calculate N. So N equals relative molecular mass by empirical formula weight. Correct? So if you do that, so this becomes 2 times 29 and your empirical formula weight. So C2H5. So this will be what? So C2. So 12 times 2 is 24 plus 5. So 24 plus 5. So if we solve that, so this is gonna be, this is going to be 2. So if you have that, now you have to get the molecular formula. You have C2H5 and the entire thing will be multiplied by 2. So that will be C4H10 and that will be your molecular formula. Let's move ahead. The vapor density of a gas is 8. What would be the volume occupied by 24 grams of gas? Okay, this is not in the syllabus. So not in course. Let's move ahead. State Gay-Lussac's law. Okay, I'm not sure if this is coming out clear to you. The question says state Gay-Lussac's law of combining volumes. So you just have to give in the entire write-up from the book. So I'm just going to tell you what that is. That is, whenever gases combine chemically, they do so in volumes, which bears a simple whole number ratio to each other as well as to the product. If gaseous provided, the conditions of temperature and pressure remains constant. Okay, so that is your Gay-Lussac's law. Alright students, let's continue from question number 5. I hope the screen is better visible now. So let's quickly do this. So if the empirical formula for compound is CH and it has a vapor density of 13, find the molecular formula of the compound. So the empirical formula is given to you. So you can find out the formula weight, empirical formula weight. So CH is given. So CH. So C is 12 and H is 1. So your empirical formula weight is 13. And your vapor density is given to you. So you can find the relative molecular mass. So that would be 2 times vapor density. So that would be 13 times 2. So you have 26. And find the molecular formula of the compound. Okay. So to find the molecular formula, you need to calculate N. So N is relative molecular mass divided by empirical formula mass. So that would be 26 divided by 13. So your N is 2. And to calculate the molecular formula, that is empirical formula and the entire thing times N, and your N is 2. So your empirical formula was given CH. So CH and whole 2. So your final molecular formula would be C2H2. Okay. So let's quickly move on to the next question. The next question is, give one word or phrase for the following. The ratio of the mass of certain volume of gas of the mass of an equal volume of hydrogen under the same conditions of temperature and pressure. Okay. So when you are comparing a gas to hydrogen, so that means under same conditions of temperature and pressure, and you're talking about a ratio. So technically over here you're talking about vapor density. So your answer is vapor density. Let's move ahead. Question number 7. Okay. So write the empirical formula of the compounds whose molecular formulas are these. So molecular formula is given to you, and as we've discussed already in mind mapping, an empirical formula is the shortest or the simplest form of your formula. So if your formula is C6H6 and you divide both the numbers by, let's say, 6. So in that case you end up by CH. What you're trying to do is you're taking out the common factor and trying to bring your molecular formula in the simplest form possible. So C6H6, you can cancel them out, both of them, by 6. So you end up with CH. The second is B6H12. You can cancel it out by 6 again. So you end up with BH2. The next one is C10H20Fe2. You can cancel the entire thing by 2 and you end up with C5H10Fe. Okay. So similarly, you have other questions given here. You can try all of them out. If there is any confusions with any of them, you can definitely reach out to me for knowing the correct answer. Let's move ahead to the next one. The percentage composition by weight and the molecular weight of some compounds is given below. Find the empirical formula and molecular formula. Alright students, so in this case I have jotted down about 15 questions here. All 15, I'm just going to do the first 2 and all of the others are your homework. At any point you can pause and take a screenshot. If you want to download this entire file, you can do that from the description box, or you can also do that from the Telegram channel. So whatever works for you, you can just get the file. Now let's get started with the first and second one. I'm just gonna cut paste this. I'll just cut paste the first one. I'll cut paste the first one and take it down. Okay, so I have the question with me now. So I have carbon, hydrogen, and I have the molecular weight given to me. Whenever again you have empirical formula questions, you start with making a chart. So you have element. So element is C and hydrogen, percentage composition 92.308 and 7.692. Then molecular mass or molecular weight. So that would be 1 and 6. No, that would be, yeah, that would be 12 and 1. And then what do we need? We need the relative number of atoms. So for that you're gonna do 92.308 divided by 12, and you're gonna do 7.692 divided by 1. Once you have the values for that, I'm just gonna use a calculator to find it real quick. Then you look for simple ratio. So let me just quickly find these first. So I have 92.308. 12, I am getting 7.692, and for this of course 7.692. So your simple ratio would be 1 and 1. So if that is the case, your empirical formula comes out to be CH. Once you have the empirical formula, you should calculate empirical formula weight. So to get that, it is just 12 plus 1, which is 13. Molecular weight is already given to you. So to find the molecular formula, you need to find N. And how do you find N? That is relative molecular mass divided by empirical formula weight. So that would be, how much is given? 78 divided by 13 that you just got. So if you look at if you know the table of 13, you would directly know the answer would be 6. Once you have that, now your molecular formula will be empirical formula and the entire thing by N, that is multiplied by N, and that would be your CH was the empirical formula. This is 6. So your molecular formula is gonna be C6H6. Let's quickly move to the next one. So next one I'll have to copy paste again. Okay, so let's get started with this one. Again, the elements that you have will be C, H and O, and this is given as 46.67 and this is 53.33. Then the weight, so for carbon we know it is 12, hydrogen is 1 and O is 16. Now let's find the relative number of atoms. So that would be 40 divided by 12, 6.67 divided by 1, 53.33 divided by 16. Let's quickly find that. So I'm getting 3.33. Of course this is just 6.67 and then I have 53.33 divided by 16. So I'm getting 3.33. Now how do we get the simple ratio? Pick up the smallest number from these, that would be 3.33, and divide all of them by that number. So if you do that, you get 1 and 1 right here, and you get approximately 2 over here. So that becomes a simple ratio. Your empirical formula will be CH2O. Okay, 2 of hydrogen and 1 of oxygen. Once you have that, directly find empirical formula weight. So if you do that, this will be 12 plus 2 plus 16. So if you do that, you get 30. Now let's calculate M. So M will be RMM, that is relative molecular mass, divided by empirical formula weight, and RMM was given to you, that is 180. So 180 divided by 30. So this becomes 6. Your N is coming out 6, and molecular formula equals empirical formula times N. Empirical formula we got was CH2O, and the entire thing multiplied by 6. So you get C6H12O6. Okay students, so I hope this is clear to you. All of the other parts for this question are based on exactly the same concept, and these are very important for the examination. So make sure that you are practicing them enough, and let me know if you have any doubts. Alright students, so this is it for today's session. Today's session was very quick and crisp, and we did go through some questions which are important. I also shared some questions which are for your practice at home. So make sure that you try out all those questions, and if you are getting stuck, you can let me know that in the comment section, and I will definitely help you out. So stay tuned, and we'll catch up in the next session.